We are now going to take a look at another example. So here I ask you to find the volume of the solid formed by revolving the region in the first quadrant bounded by this curve here, y equals square root of x minus 2, and the curve y equals 2 about the x-axis. So drawing this out, I have the region here bounded by the square root of x minus 2 and y equals 2, and then it's in their first quadrant. Well, what we're going to do is we're going to revolve this about the x-axis. Just as we did with the last example, we're going to choose a point, say this point right here, and revolve that about the x-axis to create our circle and then our cylinder. So in the end, we should have a result like this. So now notice that this cylinder is no longer about the y-axis, but it's about the x-axis. So with this, the radius is dependent on the y, and the height is dependent on where you are along the y-axis. So everything now is going to be in terms of y. To find our radius in terms of y, we're going to do top minus bottom. So here again, the simplest you can get. So we have y minus our bottom, which is x equals 0. So it's going to be y minus 0, which is going to give me y. To find the height in terms of y, we're going to have to take the original equation and solve for x. So we have y equals the square root of x minus 2. So solving for x, we're going to get y squared equals now x minus 2. So y squared plus 2 is going to give me x. This right here is our function value right here. So with the height, we're now going to be doing right minus left. And again, it's in terms of y. So right minus left, we have the function y squared plus 2 minus our left function, which is just x equals 0. So we now know that the height is y squared plus 2 and our radius is y. Using this information, we're going to find the bounds and then plug it in for the volume equation. To find our bounds in terms of y, we're going to look at the picture and decide what values of y are needed to create all those shells. So if you look, we have 0 is our lowest point, and then all the way until this point up here, which is that line y equals 2. So our bounds are going to be from 0 to 2. Another way of looking at it is just where is that solid taking place? Where is it occurring? It's occurring between 0 and 2. So now that we have our bounds, our height, and our radius, we're going to plug these values into our volume formula. So we have the volume in terms of y is equal to the integral from 0 to 2 of that 2 pi r, and we found r to be y, times our height, which is y squared, plus 2 dy. In both of these examples, we've had the radius in terms of just x or y. So no minus 3, minus 2, any other value. The next example, we're going to now revolve it about a different line, not the y-axis or the x-axis, and see what happens. We are now going to look at the exact same region, but instead of revolving it about the x-axis, we are now going to revolve it about the line y equals 3. So we have this region and revolving it about this line right here. So what's going to happen, instead of our cylinder being along the x-axis, our cylinder is going to be over that line. So we're going to have an image like this. So again, taking that point right here, revolving it, and then drawing a cylinder based off that point. So just as we did before, we now need to determine what the radius is and what the height is. But first of all, what is it in terms of? Well, as you notice, here our radius is in terms of that y, and so is our height. It is dependent on the y. So what we have is our radius in terms of y is going to be, again, top minus bottom. But our top is no longer that function. It is the line 3. So our top is equal to 3, and then our bottom here is just the y value. So it's 3 minus that y. Now, just as we did before, we have our height is going to be the right minus left. And actually, if you notice, our height hasn't changed. It is still that y squared plus 2. So recall x is equal to y squared plus 2. And we're going to have that value, so the right minus the left. So we have y squared plus 2 minus our left, which is still 0. So the only thing that changed in this case was our radius. It is now 3 minus y. So now we are ready, again, to find our bounds. To determine our bounds, we are going to look at the solid and see what y values are needed to create all of our shells. So coming over here, we notice we go from 0, and again, we only go to 2. So we stop at y equals 2. So our bounds are the exact same as last time as well. So we have y is between 0 and 2. So now with all three of these things, we can plug that in to our volume equation, and what we get is our volume is equal to the integral from 0 to 2 of 2 pi, and now our r is 3 minus y, times our height, which we know is y squared plus 2, dy. So now the only thing that changed in our volume equation is the r. It's now 3 minus y. And that was because we changed the axis of revolution from the x-axis to the line y equals 3. To generalize, we have the shell method is simply summing up an infinite number of shells rather than circles or washers. And we found if the shell slides over the y-axis, so in other words, it sits on top of that x-axis, we have the volume is in terms of x. So the radius and the height are in terms of your x. And if the shell slides over the x-axis, so it sits on that y-axis, we have the radius and the height in terms of y, and we integrate with respect to y. We also noted that the radius is in the simplest terms possible. It's either a number minus that xy value, or it's the xy minus a number. And so from all this, we are now able to determine the volume of a solid, whether or not it's a football, a soccer ball, a travel mug, hand sanitizer, lotion, and we're able to find all these using the shell method, the disc washer method, or even the original method of just finding the cross-section areas.